Hi there, and welcome to this course. I'm Kevin. I'm a solution architect and I've worked in the IT industry for more than 20 years, and I'm a Microsoft MVP for more than 10. My focus these days is architecture and security for web applications and integration components using .NET and Azure. It's hardly a secret that cloud-based computing is everywhere, and that every developer should know what it is and how to use it. In this course, I'm going to teach you the basics of Microsoft's cloud offering, Azure. I hope you'll enjoy it. Let's have a look at what exactly you will learn in this course. I'll start with explaining cloud and Azure basics. What is cloud computing? Why would you want to use it? What is Azure? What are its benefits and how is it organized? Then I'll cover a set of often used core Azure services. You will learn how to create, manage and deploy two Azure App Services used for hosting your web apps and APIs. You will learn how to work with Azure Storage, from table storage, over storing blobs efficiently, to working with queues. I will also dive into Azure's SQL offering, the go-to relational database offering in the Microsoft Cloud world. When you're developing on Azure, you will, just as with local development, need to debug, log things, inspect logs and get an overall overview of your app performance and health. That and more is covered in the section on debugging and logging and working with application insights. And lastly, you will learn how to monitor Azure resources. After this course, you will have learned all you need to know to start developing on Azure. Let's have a look at what the prerequisites are and then dive in. This course is aimed at developers, architects and consultants that are mostly new to Azure. You don't need to know anything about cloud development yet, but you do need to be a developer, consultant or architect with experience with building applications with .NET. For example, throughout the course or course series actually, we'll be working with various Azure services which we will use to create or move parts of a typical application, like a web application built with ASP.NET Core that connects to a SQL database via Entity Framework Core to the cloud. Building that initial web API with ASP.NET Core which connects to a database with Entity Framework Core is not part of the course. It is something that I assume you already know how to do. But that's about it as far as prerequisites go. As far as code is concerned, where applicable, each section has its own starter and finished sample solution, so you can use that to follow along. I'd advise you to follow the course from beginning till end, but it is not a strict necessity. You can also jump in at whichever section you choose. The starter solution will always match the beginning of the section. The finished solution will match what we end up with after the section. So there you go. That's it for the intro section. Let's dive in. Imagine a world where you can focus entirely on writing your code, without worrying about the underlying infrastructure. That is the promise of serverless computing. In this approach, Azure takes care of all the infrastructure management for you. Next to that, your applications can automatically scale up or down based on demand, and you only pay for the resources you actually use. In this section, you will learn all about serverless computing and why you'd want it. We will compare traditional architectures with serverless architectures, and we will look at how what we learned in the Getting Started course fits or doesn't fit in the serverless paradigm. Let's dive in. Let's talk about serverless computing. It's a model that has been gaining a lot of attention and popularity over the last few years. In essence, it's a cloud computing model where the cloud provider, Azure in our case, automatically manages the infrastructure. That allows us to focus on writing code without having to worry too much about that infrastructure. Now, managing the infrastructure in the context of serverless computing should be interpreted broadly. Of course, it means that you don't need to worry about managing your servers, but it goes beyond that. Typically, serverless systems should automatically scale up or down based on demand. Next to that, the pricing model is pay as you go, which means you only pay for the compute resources you effectively use. Billing is based on the number of executions, duration of the execution, and or the amount of resources consumed. This type of model is also typically event-driven. A function call or a workflow is typically triggered by an event like an HTTP request, a file upload, a database change, or a scheduled task. The approach obviously has some benefits. Reduced operational overhead is one of them. There's no need to manage servers or infrastructure, which leads to faster development and a lower time to market, because you don't have to worry about this anymore. Cost efficiency is another one. You pay only for the compute resources you use. Okay, so what can you use it for then? The serverless approach on Azure can be used for a variety of application scenarios or patterns, most of which you're probably used to already. First of all, API or function calls. Who hasn't written something like that yet, right? Then the application environment host itself, that to which you deploy your app. Typically a web server or a set of them, potentially behind a load balancer or a firewall. Creating workflows is another typical thing a lot of us need to do that can be serverless. Something along the lines of, if the sale is for a large amount of money, it should be sent to the manager for approval first. Things like that. We've all written that, right? For those of you old enough to remember, and I'm afraid I am, there used to be something called Windows Workflow Foundation, released together with the full .NET Framework 3.0 back in 2006. That was something that made it easier to code flows like this. If you're building an API, you've probably used or even built an API gateway. These are commonly used to handle routing, security, rate limiting, request and response transformation, caching, and more for your APIs. In case you're working with containerized microservices and you've got more than a few of them, you'll likely have encountered the need to use an orchestrator like Kubernetes. That too is a good use case for the serverless approach. And lastly, your data stores, be it queues, blob containers, databases. These too have serverless alternatives on Azure. In fact, let me map these to Azure services. API and or function calls can be matched to Azure Functions. Your application hosts can be matched to Azure App Services. Workflows can be created with Azure Logic Apps. Azure offers an API gateway in the form of Azure API Management. There's a managed Azure Container Orchestrator, the Azure Kubernetes Service or AKS. And lastly, Azure SQL and Azure Storage are Azure's managed data store solutions. And there's undoubtedly more, all of which can be developed with a traditional approach or with a serverless approach. Now, if you've followed the first course in this series, some of this may sound strangely familiar. We used App Services there to host our API. That is a platform as a service offering, which means that the management of the infrastructure is already delegated to Azure. We also used Azure Storage and Azure SQL in that course. Again, two platform as a service offerings with the advantages that come with it. And all the other scenarios in Azure services I mentioned also come in a platform as a service offering. So indeed, the serverless approach on Azure is inherently tied to the platform as a service offering, as by using this we already delegate the management of the infrastructure to Azure. The Azure services we will dive into in this course, like Azure Functions, Logic Apps, APIM and Event Grid, are also all part of the Azure platform as a service offering. Now, that doesn't mean that by definition you are working serverless when working with one of the platform as a service offerings. As we just learned, the serverless approach is characterized by more than just that. Other characteristics were automated scaling and the cost efficiency that comes with only paying for the compute resources you need. Pay as you go. That is then typically combined with event-driven approaches, although that last one is not a must. Combine these and then you've got a serverless approach. While automated scaling and pay-as-you-go can often be enabled for platform as a service services on Azure, you don't have to do that. You will notice that many of the services that can be used in a serverless approach can also as easily be configured without automated scaling or with a different cost model. We learned about that already in the Getting Started course, where we learned we can manually scale instead of automatically, and where we also learned about the various cost models enabled via, for example, the app service plan, many of which are not consumption-based. I will show you throughout the course how you can configure these settings for other services where applicable. Nevertheless, I thought it would be a good idea to use this serverless paradigm as sort of an overarching framework to tie all of these topics together. Because in your day-to-day life as an Azure developer, the serverless way of working will only become more prominent.